hard to hear me? Can you hear me now? All right. Usually I'm loud enough. I apologize. All right, so basically we're looking at the expressing security risks. How do you express a risk when you don't understand the vulnerabilities and how they're leveraged? You need to have offensive skills in order to maximize understanding and how vulnerabilities can be leveraged. And you need to be able to demonstrate proofs of concepts in order to help others understand what's really happening. If I tell you this is bad and it can be broken, but I can't actually show you how it can be broken, you're probably going to be like, oh, but it's bad. You're just going to pull it off. But if I could turn around and I could tell you this is bad, this can be broken. And by the way, I can show you real quick how your enterprise has got major problems. All your customers' credit cards are easily acceptable or anything like that. So basically, you just got to understand what risk is, what is the risk, and can you convey that risk to C-level people within the organization and make sense of it. Just saying something's bad is not good enough. You got to actually be able to prove that what you're saying can be done, or you better know somebody that can at least, or it's going to be really hard to believe you, or not really to believe you, but it's really hard to express the true risk of the issue if you can't show somebody how it's done. All right, so battle plan. We're going to take one vulnerability, or how bad can it be? So what about it if it's internal to an enterprise? How can it be leveraged to further compromise the network? Let's investigate, concentrate on one vulnerability, exploit it, use the Windows hashes to cause havoc. Figure out how bad it can be and how easy it is to figure out what to do about it. So if you can't tell, I haven't really looked at these slides much, and it was a long night. You good?
So when you see something like this, how do you express how bad this is? So OMG XSS. I mean, obviously, for something like this, there's a cross-site scripting vulnerability. But how do you express how bad this is? Or what about this? In this instance, we have some code which was not coded optimally. So before it actually checks some things that are set by the server, it checks some things that are sent by the client. And that's not always optimal. You'd much rather trust the server in most cases than you would what the client's sending you. So let's really find out. Let's start. We're going to exploit a cross-site scripting vulnerability, and we're going to use that to hook an admin user. And by hooking, I mean not to show some leg and get some action, but I mean more along the lines of we're going to take control of the admin's browser and make them do funny things. So then we're going to steal the LM challenge hash, which the LM challenge hash is part of Windows integrated authentication. A server which you're trying to connect to will say, okay, so you want to connect to me. Here's this little challenge that is supposed to be random for you to encrypt your stuff with and send it back to me. So in this case, it's not going to be so random, which takes down the attack space that we have to work with in order to actually attack that hash and turn it into a usable password. And so then we're going to do some more with exploiting and popping boxes and breaking shit. And then we're going to discuss some other attacks if we have time, which we probably won't. So again, after this, if you want to find out more, you want to break more stuff, we're going upstairs and bring your liquor. So what we're going to be working with today is the Samurai Web Testing Framework. And the first thing we're going to look at is the actual a blog. And this is a blog that we might have found internally. And the little piece of code we looked at is actually from this blog. So the unfortunate thing, again, is that this application trusts what the user is sending it. And as part of all these little things and forums and stuff like that, you see the little, if you're an admin user, the IP address of the person who posted. So it's checking the IP address of the user that posted based off of what the user sends it. So when they see that little piece of information, maybe we can control that and do some naughty stuff with it. So we're going to do some naughty stuff with it. So the first thing we want to do is we want to look at the actual comment field. And so we see that there's some information here. We're going to use a tool called Tamper Data within Firefox, and it comes by default with the Samurai Web Testing Framework distribution. And so we're going to come down here and open up Tamper Data, and we're going to start tampering. And we're going to fill in our blog comment and something random. And not drunk enough yet. So, and then, you know, this really, the protection for all of this, you know, this makes it secure. So we're going to post this, and it's going to give us the option to intercept this and start playing with it. So we see a couple of things here. Over here on the right-hand side, we see all of the different parameters that we're sending as part of the form. And then over here on the left, all of this is information that the client is sending based off the headers. And as part of a web conversation, headers are basically like the set of parameters that let us have an intelligent conversation. So when I say hi to Brian, and I've addressed him as Brian, so he knows I'm talking to that personality. And we've established that we're speaking English or some sort of weird Southern dialect. And you know, we've set up some other parameters. We're speaking friendly, and I'm not calling him names yet. So in this situation, that script was checking to see what IP address the client said he was using. So what we're going to do is I went ahead and pre-prepared some stuff. And so I'm going to add a property to this. I'm going to add in the client IP address, which is what that script was checking. And instead of that, I'm going to replace it with the script that will allow me to hook a client with a program called Beef, which is the Browser Exploitation Framework. And this would be known as Beef Injection. So, well, some would say it is hot. So we're going to take the client IP address, and over here, the server was nice, and it gave us a hidden field with our IP address already in it. And so just to make sure it doesn't get confused, we're going to put our same script in there, and we're going to go ahead and submit that. And we see that, awesome, our comment was added. So we can go back to our comments and make sure, oh, yep, Joe Bobber's not drunk enough yet. So from here, we want to set up our beef. As part of the default installation of Samurai, it comes with Beef. So when you download the Samurai Live distribution, you get this by default. I've upgraded this to the latest version. So when you go to your local host, which is, in my case, my name is samurai.mydomain.com, and go to the /beef directory, you see the configuration screen. And this is ultra secure. It fills in your password for you, so all you have to do is hit apply config. And of course, since this has to be open to the rest of the world, you know, your mileage may vary but this is not obviously a ultra secure configuration. So, also it tells you the default here, which is what it's filling in for you. So, like I said, not ultra secure. So we're going to apply this config. We're going to go ahead and finish that up. So here we have Beef. One of the first things we want to be able to do, yeah, moo cow, awesome. So one of the things we want to do is we want to be able to communicate with Metasploit, because Metasploit is how we're going to do some of our breakage. So I wrote some additional stuff for Beef that Wade Alcorn, who's the program's maintainer, included. And one of them is a program that will let you communicate directly with Metasploit. So by default, if you haven't set anything up, it doesn't know how. So you'll see this load failed check logs. So what we're going to do is we're going to copy this, and I already have a copy of MSF console loaded. So we're going to go ahead and paste that in. And what we've done now is we've started up an XML RPC interface. An XML RPC is a protocol that will allow disparate systems to communicate. So in this case, a PHP web application and a Ruby console application are going to be able to communicate back and forth. And we're actually going to have the web browser launching Metasploit modules on its behalf. So we're going to go back to our beef, and we're going to reload real quick. And when we go back, we can look at the browser exploit, and we see all of the different types of browser exploits that Metasploit has with it. So we see that this is working, and with this module, we would be able to pick a specific exploit and toss it at whoever's connected. So what I'm going to do now is I'm going to go over to my trusty Windows XP, and this would be my admin user. He's successfully logged in, and when he goes to view the comment, over here, you don't see any IP address. You don't actually see anything. There's nothing that says, wow, this is some naughty shenanigans going on here. So over here, though, we see that we now have a new client for beef. So if we come under zombies and we click there, on our host, we see quite a bit of information. We see it's running Internet Explorer. We know what the resolution is. We know what the page is. And so it'll even allow us to show the page content. So if this was, say, a banking application or something like that, you may be able to actually see the content on the banking application as the client would see it, where you wouldn't normally be able to do that. So what we're going to do is we're going to take advantage of Windows Integrated Authentication, which basically what happens is if a host is in your intranet zone, which when you look over at the bottom of Internet Explorer, down here, you see that I can't bring it back on the screen. You see local intranet, which local intranet is a special zone that is for your local network. And this has a special trust relationship where if you have a Windows client and it's part of the local intranet zone connecting to a Windows server, if the Windows server supports Windows Integrated Authentication, they will basically agree on a relationship where the Windows client will pass their password hashed with a challenge that the server sets. So because we control the server, we control that challenge, and then we're back down to just the password hash when we're cracking. So what I'm going to do is I'm going to come under here for the browser modules and choose the SMB challenge theft. And from here, I'm going to accept all the defaults, and I'm going to keep our zombie selected over here, our admin user, and we're going to send now. And so over here on the right, we see that Metasploit has launched the SMB exploit, which basically starts up a listener waiting for the client to connect to it. And then in a minute, it gives it a second for the Metasploit to start it up, and then it's going to send the client over there behind the scenes. So the client's not even going to know that any of this has happened. And then at that point, we will actually have a workable hash that we can turn into a password. So our module code has successfully been sent. And so what we can do now is Beef has already given us these helpful tools to look at what our captured hashes are. So we can just save this and then we can go over to a shell window and we can look at what we actually have. So if we look at this, we can see that in a normal scenario, we would have grabbed a couple different users. And we have from here the username, domain, our static challenge that our server always sets. Then we have our LM hash and our NTLM hash. So from here, we want to turn these into real credentials. So the fastest way to do that is with plaintext.info. Who's heard of plaintext.info? Awesome. So since I don't trust y'all enough to get on the internet, we're going to do a little video. So basically what we're going to do to start off with is we're going to get the half LM challenge hash out of this, which LM is split into two separate pieces of 7 characters. So for the most part, people don't much use more than the first 7 characters. And so if they do use more, then those are pretty easy to brute force instead of trying to figure out both halves. So what we're going to do here is we're going to just grab the LM part, and then we're going to only pull the first 16 characters, which is the half LM part. And do you want to talk about what happens next, or you want me to do it? Yeah. So we're going over to plaintext.info, and if you want to.
So plaintext.info, I'm actually the founder of it back in like 2002. But basically what we're going to do is we're going to come over to plaintext.info. We're going to drop in basically that encrypted hash. So we're going to drop in the hash over at plaintext. So we go to add hash. And as an anonymous internet user, you do have the ability to submit hashes, but there is a limited number. So we go to paste them in, select the hash algorithm you're using. You got to type in the security code. It's a little better than the last one with that blog. Hit send, and that's going to submit it over. So when plaintext receives your hashes, what ends up happening is, so I'm going to like, you still playing here? All right.
Over at the IRC portion. You want to talk about it?
Yeah. So when a hash is sent to plaintext.info, if you do it through the web interface, it's sent to a back-end client cracking server infrastructure. So you have client crackers that are people that volunteered to give us some of the CPU cycles, and they're hosting Rainbow tables, word lists, or high CPUs for brute forcing. And then there's also a IRC side channel that has bots in there that you can just talk to the bots and give them your hashes. They'll break them for you. You just hang out in the interface, hang out in the room, and they're going to give you back the decrypted password for you. So we've got we've got the integrated web and client, and then we also have the IRC side with bots that are already sitting there waiting for your backend hashes to crack them. And
so from here you can see that because this works on different levels, the first phase of plaintext is it compares against word lists. And word lists, because of the way that plaintext does them, are very fast. So you can see that within a couple seconds, we got back 2 of those hashes. If word list doesn't work immediately, then it will go down to using rainbow tables. And so rainbow tables take a little bit more time. If you hang out in the IRC channel, you'll either get them or you won't. Because rainbow tables are sort of hit or miss, but rainbow tables are a whole lot faster than brute force. So the goal is really to get some foothold to further what you're doing. So at this point, we've got 2 users here that we've gotten. And so when we look for this hash, the 271F, let's go back into here. We see that user is Jen. From here, we can use Metasploits tools to turn this into a usable password. So the first one is the half LM second tool. So what we're going to do with this is we know that this portion right here is our password. So we're going to take this and we're going to go up and we're going to type in -n, and our hash, we're going to do -p, and we know that our password was Tiffany. So from here, we got, there was one additional character. It turned out to be an 8-character password, and that last secure character at the end was the percentage sign. So because LM is case insensitive, we now need to turn this into a case sensitive password. So to do that, we want to go back into tools, and there is an LM to NT crack. And I modified this so that it can use the challenge. And so from here, we're going to take our NT portion, which is that second half of this goodness, and we're just going to copy this over real quick. And then we need to pass in our password, which is TIPHANY percentage sign. And so now at this point, we have the case-sensitive password to use. So at this point, we've gone from a cross-site scripting vulnerability all the way to a usable password. And again, our admin user really has no clue
Never seen this come.
that
Didn't know it
any of
happened.
this has happened.
All in the back end.
So what we've done here is we've taken a relatively simple exploit, and then we have sort of leveraged some of the other types of vulnerabilities you'd find within a typical enterprise, and we've used those vulnerabilities in conjunction with our cross-site scripting in order to turn that into a usable password. But I said we'd break some stuff. So if that didn't work, there's some other fun stuff that you can do.
With your beef.
The first thing I'm going to do is I'm going to go back into Metasploit, and I'm going to kill the jobs that are running right now just for ease so that we can see exactly what all's happening. But there is another browser module called MSF Browser Autopwn, which this again talks directly to Metasploit. So when we set up the default options, keep our browser selected, the only thing that we have to add in is our IP address. So we'll grab our IP address real quick, which this is my IP address for easy hacking later. And we'll come back over here and we will paste this in here. And now all we have to do is highlight it and hit send now. And again, over here, we see that Autopwn exploit has been launched. So what's happening in the background is Beef told Metasploit to fire up browser Autopwn. If we pop on over to Metasploit and type in jobs, these are all the different things that are now running in Metasploit, which I didn't explain it, but Metasploit is a penetration testing and exploitation tool. Allows developers to quickly build up exploits and then to use them in penetration tests. So all of this has been open. We can see that we just got 2 sessions, but over here we see that it was successfully launched over to the user. The user will see something interesting here, and that right now you can see down at the bottom, pages are loading and now it's hanging. So the user will eventually kill their session. But for right now, we probably want to see what things we actually have running. So doing sessions list, we'll see that the browser IE create object got a shell and browser MS06067 keyframe got a shell. We're going to interact with one of those real quick. And so this is Meterpreter. Meterpreter is like a client that gets injected as a DLL as part of browser Autopwn. So we can see that we're now in the system as the Cicero user. When we can see that we can actually pull a directory listing. When we type in help, we can see all of the different things that we can do here. There's an additional module we can load in called priv. So we type in use priv and type in help again. We see a couple more options. One of them is hash dump. So from here, we actually have all the LM and NTLM passwords again, and we can go back to plain text through another and try again, and we have another shot at a whole potentially different set of users. In a lot of cases, potentially some domain users. So that's another way to go about it. Now,
if you got the domain controller, you'd have everybody's account.
So for this, like I said, it's hanging. So somebody's eventually going to hit X. So one of the things we want to do is we actually want to migrate this to another application that's running on the system that somebody's not going to get frustrated and close. So we can type in PS, and we can look at all the different things on here. So you know, there's lots of different things we might want to migrate to. Until they log out, Explorer is going to be hanging around. So so we're going to go over and migrate to that process. And it takes a second, so you know, if it takes just a second, don't get frustrated. And so now, you know, we look, we're still good. And so now when this person is like, screw this sucks, they're going to hit close, and we're still going to be connected over here. And yeah, no, Microsoft doesn't need to know about that. So we still have the same privilege level, and we can still dump all of the goodies.
Would you say that migrating from an IE session would be one of the first things that you do?
Yeah. Well, I guess it depends on how frustrated you expect the other person to get. Most of them probably won't be very tolerant of the fact that we're doing a presentation. So Typically, you might want to even set up a script or something like that that would run first thing that would migrate you to a more stable process. So the other thing, we saw multiple processes. When you start doing sort of what we did with Autopwn is we basically said, we don't know what of these is going to work, so we're just going to throw a whole lot of crap at this browser. And so unfortunately, some of those are going to be less stable because some of the other ones that ran after it have potentially screwed us up. So you may actually have to go to more than one in order to get a stable session. But that is even more important, where as soon as you've got in, you want to migrate into somewhere more safe. And so I'm going to just go back to the slides right now because I know that we're probably short on time. And so.
All right, so great, we broke stuff, so what? Do you feel like you understand some of these risks better? Do you feel these risks were difficult to execute? Nothing here so far, by the way, was like heavy coding. I mean, most of this is point and click you didn't notice. Are you a little concerned now? Being able to express and demonstrate how these types of vulnerabilities are leveraged increases impact and buy-in. So if you went to a C-level guy and said, we got a problem, he's going to be like, yeah, we got a lot of problems. But if you can go through maybe middle management or somebody else and say, we got a major problem, let me show you, and you click a few buttons and all of a sudden you have the CEO's hashes, you broke them and you hand him back his password, he might listen. Go ahead. All right, so remediation. That's kind of a hard one because, you know, as security professionals, we understand that this is a very changing landscape. Every time we patch one thing, something else comes up, right? So some of these slides say, I mean, I don't have to sit here and read them to you, but basically, you know, there's no silver bullet to solve every problem. It's not like you're going to go buy a firewall and everything's better. The best thing you can really do, like I said, is to set practices, policies, guidelines, encourage people to do the right thing with security, and train every employee. Even if it's the janitor that has an email account. You got to make sure everybody understands what's at risk. And, you know, just leverage the organization and make sure you have strong policies and procedures, and that'll provide you a lot more than the basic chasing the issue and, you know, patching every third Tuesday.
And this goes back to what we said at the beginning, which the initial premise was, so why do we need to have security professionals with offensive security skills? And so making sure that at least somebody on your staff really understands how all of these pieces chain together and play into the overall security of your network is really important. And there really is not a silver bullet, but you know, if you don't understand really what you're dealing with, how do you adequately protect that? So here's our contact information.
Yeah.
Okay, you got that. So and here's a bunch of links. And if you have any questions or anything else, don't want to take up too much of people's time, but you can come upstairs, 9th floor. We're gonna.
Yeah, we'll grab the projector. We'll go up there, and anytime during the day, because you know you might want to see you're probably gonna want to see the next talk. So I'm not asking everybody to leave and follow us up there and link the next guy if nobody there. We're gonna be upstairs. We're gonna be around. Listen to the other talks. Try not to be too crazy drunk when you come to see us. But you know, if you have any question whatsoever, we can go a lot deeper. We can go step by step, and we can make sure you understand what was done here. Because some of you may not really fully grasp what we did. You kind of thought it was cool. All right, we got into this. But we can go over it when we have more time upstairs and cover any questions you might have. Something you may not want to ask in front of the audience, kind of thing.
So if anybody has any questions, real quick. Awesome. So
Thank you.
Go ahead. Thank you.